Hello everybody, I am Shomokantigiri. Welcome to my channel. So today I will discuss about Niosome. Okay. So in this video we are going to discuss what is Niosome, classification of Niosomes, then advantages of Niosomes, then ingredients of Niosomes. Okay. And you will find that ingredients, in case of ingredients, we use different types of ingredients like cholesterol and surfactant, and we will discuss in this video elaborately about the role of cholesterol and DCP, diacetyl phosphate, and surfactant on the formation of Niosomes. Okay. Then we will discuss about the factors leading to Niosome formation like Hlb value, CPP, critical packing parameter. Okay. Then we will discuss about methods of preparation, like important जो मेथड होता है ना वो हम लोग डिस्कस करेंगे. देन उसके बाद वी विल डिस्कस अबाउट द इवेल्युएशन ऑफ न्यूजम्स. ओके, सो दिस इज आवर एजेंडा today. So let's jump to the topic. This is the brief introduction about me. Okay, so let's jump to the topic directly. So what is Niosome? Niosome होता क्या है? Niosome is a vesicular drug delivery system. Okay, it's a vesicular drug delivery system like liposome. Okay, so I have made a dedicated video regarding liposome. If you want to see the video, I am giving the link in the description box as well as in the I button section. Okay, so have a look. So Niosomes and liposomes, both they are your vesicular drug delivery systems. Okay, and the application of Niosome was started in case of your cosmetic industry. Okay, so both of them are coming under in your NDDS, novel drug delivery system. Okay, so classification of Niosomes. देखो Niosome देखता कैसे है? देखो, this is the Niosome. Okay, two parts are there. Okay, now one is your core section. Okay, and another is your bilayer section. Okay, so this is your Niosome. Okay, coming to the next point, classification of Niosomes. Niosomes can be classified according to their size. Okay, small unilamellar vesicle can be there. Okay, large unilamellar vesicle, it can be large unilamellar vesicle. Then multilamellar vesicles also be there. And just see the size range. Okay, 10 to 100 nanometer, your generally 10 to 100 nanometer size is for your small unilamellar vesicle. 100 to 10,000 nanometer, 3000 nanometer is your for large unilamellar vesicle. And in case of multilamellar vesicle, your size is beyond 1000 nanometer. Okay, so this is the structure of your Niosome. You can easily understand that this is the core portion and this is your bilayer portion. Okay, I will elaborately discuss about the structure and components of the Niosome. Okay, so don't worry. So advantages of Niosomes. Advantages of Niosomes. The biggest advantage regarding Niosome and liposome. Okay, both hydrophilic and lipophilic drugs can be incorporated inside the your Niosome as well as liposome. Okay, so this is the biggest advantage of Niosome. Okay, and sometimes Niosome can be your biodegradable and non-immunogenic. See, we use Niosome with the help of non-ionic surfactant. Okay, non-ionic surfactants. So non-ionic surfactants are generally your non-irritant. Okay, so that's why they are non-immunogenic also. So the Niosomes are biodegradable and non-immunogenic. In case of Niosome, they also offer sustained and controlled drug delivery system as well as targeted drug delivery system also. Okay, and they also provide high patient compliance. Okay, so these are the advantages of Niosomes, and you can easily understand these portions. Okay, so coming to the next important point regarding the ingredients of Niosomes. Okay, so in case of Niosomes, three major ingredients are there. One is your non-ionic surfactant, then cholesterol, then your charged molecule. Okay, if you go through the liposome, then you will find that surfactants are not used there. Okay, surfactants are not used there. In case of surfactant, they used phospholipid. Okay, phospholipid. So this is the basic difference between Niosome and liposome. Okay, apart from that, generally all are same in case of both. Okay, and charged molecules are also used in case of Niosome and liposome. It is positively charged, and diacetyl phosphate DCP, it is negatively charged. Okay, so these are generally used for your Niosome formation. Then coming to the most important topic, like importance of surfactant. So why surfactants are used in case of Niosome formation and what are their critical rules? Okay, so let's understand this portion, this topic very well. देखो surfactant होता क्या है? देखो surfactant होता है It's a amphiphilic molecule. Okay, it's an amphiphilic molecule. That means it's have two end. One is your head portion and another is your tail portion. Okay, and the tail portion is lipophilic, lipophilic in nature. Okay, and the head portion is your uh, hydrophilic, hydrophilic in nature. That means it is your water loving, and the tail portion is water hating. I mean lipophilic. Okay, lipophilic. I mean oil soluble. Okay, it can soluble, easily soluble in your oil. This portion, tail portion. Okay, so the लिपोफिलिक रीजन, जो लिपोफिलिक रीजन होता है ना आपका जो सर्फेक्टेंट है ना, उनका जो लिपोफिलिक रीजन है, आई मीन टेल पोर्शन, generally made up of your alkanes, fluorocarbons and aromatic compounds. Okay, that is the main point. And the head portion means your hydrophilic portion. Head portion means your hydrophilic portion. That hydrophilic portion actually contains sulfonate, ammonium derivative compounds, phosphonates, etc. Okay, that is the basic structural difference between head and tail. And one more thing, the surfactants can be classified into following categories like anionic surfactant, cationic surfactant, amphoteric surfactant and non-ionic surfactant. So let's understand what actually it tells. Head portion, this is your tail portion, and this is your surfactant. Okay, this is your surfactant. If the surfactant molecule's head portion contains plus ion, I mean plus charge. Okay, if the head portion of your surfactant molecule contains plus charge, then it will be named as cationic surfactant. It will be named as cationic surfactant. If the head portion contains minus ion, I mean anion, then it will be considered as your anionic cation. Okay, if the head portion does not contain any ion or any charge, then it will be non-ionic. Surfactant. Very important topic, very important information also. Please do understand it. Okay, then in case of amphoteric or deuterionic surfactant, what happens? In case of amphoteric or deuterionic surfactant, the head portion contains both positive and negative ions, or positive and negative your charge. That's why they are known as your amphoteric surfactants. Okay, so I am not getting into the your so-called examples and etc. So I am directly going to jump into the topic. Those are important to your Niosome formation. Okay, I have a request to you. Please go through the book and just easily try to understand the classification of the surfactants. Just have a look at that. Okay, I'm not incorporated here. Okay, so if a surfactant contains head with two oppositely charged group, they will be known as your deuterionic, already discussed. And the most important surfactants for Niosome preparation are your twin 20, span 20, twin 40, span 40. All are used in case of your Niosome formation. Then coming to the next point, importance of cholesterol and DCP, diacetyl phosphate. Importance of cholesterol and diacetyl phosphate. What are their role? Okay, so cholesterol have some kind of surfactant properties. Okay, that is good. Okay, and one more important thing is that cholesterol have tremendous impact on your entrapment efficiency, drug entrapment efficiency, and drug release and stability. Okay, so drug entrapment efficiency means if you are making Niosome, okay, with your 100 mg drug, let's say, okay, and Niosome vesicle contains only 80 mg, so that means your entrapment efficiency is 80%. Okay, so that's the basic concept. So entrapment efficiency, drug release, and the vesicle stability, all these are impacted by the cholesterol and your DCP, diacetyl phosphate. Okay, so again the amount of cholesterol and DCP should be optimized because of the stability of the your vesicle, and in case of drug release, most of the time you should optimize the formulation with your cholesterol content and DCP content. DCP means your diacetyl phosphate that is having your negative charge. Okay, and it will provide actually electrophoretic mobility for Niosomes. What is electrophoretic mobility? That means all of you know that your extracellular portion, suppose this is cell and this is your extracellular environment contains sodium ions, that is your positive ion. Okay, that is your positive charge. Okay, and in case of Niosome, if you use your DCP, diacetyl phosphate, then the Niosome molecule will have some kind of negative charge on it. Okay, so the gradient, the electrostatic difference, okay, electrostatic gradient will attract your Niosomes, negatively charged Niosomes, to the cellular environment, to the extracellular environment, and it will actually help in case of transportation of negatively charged Niosomes. Okay, that is your electrophoric mobility. Okay, and again the limit DCP content should be optimized, okay, for the formulation. Then coming to the next point, factors leading to Niosome formation. Okay, there are several factors, like the main factors are your thermodynamics, then Hlb value of the surfactant, then critical packing parameter, then effective area per lipid chain. Okay, these are the actual factors, those actually have good impact on your Niosome formation. Okay, so in case of Hlb value, see, all of you know the what is Hlb value. It's a dimensionless quantity to memorize the property of the your surfactants. Okay, so in case of Hlb value, it is also having a great role in the Niosome formation. Okay, and in different experiments it has been found that sorbitan monostearate, commonly known as SPAN, okay, SPAN का जो Hlb value है ना 4 to 8, that is actually good for your Niosome formation. If you are using SPAN to form Niosome, then the Hlb value 4 to 8 is good for Niosome formation. Number one thing. Number two is Hlb value should not be beyond 17 or 14 to 17 Hlb value. Actually, surfactants having Hlb value 14 to 17 does not form Niosome. Okay. Then coming to the critical packing parameter. Critical packing parameter means it's also a dimensionless property of surfactant. Okay, the equation is written here. What is the equation? CPP is equal to your V by LC alpha 0. Okay, so what is V? देखो V is the volume of the hydrophobic chain. जो सर्फेक्टेंट जो है ना आपका, जो ये जो सर्फेक्टेंट वाला है ना, इसका जो हाइड्रोफोबिक चेन है, ये तो हाइड्रोफोबिक चेन है ना, इनका जो वॉल्यूम होता है, एंड द लेंथ ऑफ द हाइड्रोफोबिक चेन इज LC and V is the volume of the hydrophobic chain and L is the length of the hydrophobic chain, and alpha 0 की alpha 0 is the area of the hydrophilic जो हेड होता है ना, उनका जो एरिया होता है ना, हाइड्रोफिलिक जो हेड है, ये तो आपका हाइड्रोफिलिक हेड है, उनका जो एरिया होता है ना, वो होता है अल्फा 0. ओके, सो दिस is the impact of CPP value in the vesicle formation. Okay, देखो CPP value होता क्या है? CPP value less than 1/3 हो सकता है, 1/3 से 1 मतलब हाफ, वो भी हो सकता है, मतलब लेस देन 1/3 एंड सॉरी ग्रेटर देन 1/3 एंड लेस देन 0.5, ये भी हो सकता है CPP वैल्यू. एंड CPP वैल्यू ऑल्सो कैन बी ग्रेटर देन हाफ, लेस देन 1, ये भी हो सकता है, एंड CPP वैल्यू कैन बी ग्रेटर देन 1, ये भी हो सकता है. बट इन केस ऑफ bilayer formation, CPP value, I mean bilayer formation means liposome formation. Liposome is a bilayer, okay, structure, and Niosome formation. The CPP value must be half to 1. That means greater than half and less than 1. You can see the structure of the bilayer. Okay, so to form bilayer structure, the CPP value should be greater than half and less than 1. That is very important. That can be asked in your different exams, like if you are preparing for NIPER JEE PhD in pharmaceutics, then it is a hot topic for them. Okay, you can see the spherical structure, cylindrical micelles are there, okay, inverse micelles are there, and you have to memorize the value of CPP and their impact, okay, and the equation. That is important. Then coming to the next point, the effective area per lipid chain. What is it? It is often denoted by AC. Okay, AC. That is often denoted by. See, this is your head portion and this is your tail portion of the surfactant. Okay, so if you consider the area of the tail portion, the cross sectional area of the tail portion, that actually is indicated by your AC, the effective area per lipid chain. Okay, and in different studies it has been found that the AC value above 0.43 millimeter square actually helps to form micellar structure. Okay, and the AC value less than your 0.43 millimeter square prefer to form multilamellar structures. Okay, so again these are the theoretical portions, theoretical data, and the reference are already added. So coming to the next one, methods of preparation. So there are several methods, like handshaking method is there to form Niosome, thin film hydration is there, okay, pro-Niosome technology is there, okay, freeze thaw method, freeze and thaw method is there, okay, then sonication technique is there, reverse phase evaporation is there, ether ejection method is there. I am not going to discuss each and every topic, but the important ones are discussed by me. Okay, so let's see what is thin film hydration method. See the image very carefully. Okay, in case of thin film hydration method, what is the name? Thin film hydration method. That means you have to first prepare a thin film. Okay, after that you have to add water, क्योंकि hydration बोल रहा है. Okay, so you have to first prepare a thin film, then you have to add water. Okay, so you have to first prepare two solutions. Okay, one is aqueous solution and one is oil solution or lipid solution. Okay, you have to incorporate it cholesterol, and if the drug is oil soluble, then you have to add drug here. If the drug is aqueous soluble, then you have to drug in the aqueous solution, and you have to prepare these two solutions with three ingredients which I have taught earlier. What are those? Cholesterol plus your surfactant plus your diacetyl phosphate or charged molecule. Okay, so these three are used. You have to prepare two solutions, one is oil solution and one is aqueous solution. Okay, so surfactant and cholesterol should be mixed in your oil solution, and if the drug is soluble in water, then the drug will be dissolved in the aqueous solution. After that you have to actually go for rotary vacuum evaporator. Okay, you have to go for rotary vacuum evaporator and evaporate the oil phase. And a thin film will be produced inside the wall of the round bottom flask. Okay, so you have to first make two solutions. Okay, one is aqueous solution and one is your oil solution or lipophilic solution. After that, the oil solution you have to pour in the your round bottom flask, and the round bottom flask should be entangled with the your rotary vacuum evaporator, and the evaporator will be run and your organic solvent will be evaporated easily. Okay, and a thin film will be formed here. After that you have to add the aqueous solution inside the thin film, and inside the round bottom flask containing thin film. Okay, and you have to go for rapid sonication, immediate sonication, and your Niosomes will be formed. That is the basic method, thin film hydration. Okay, so coming up with the next method, ether injection method. Ether injection method में होता क्या है भाई? देखो, same case, you have to prepare two solutions. One is your organic solvent and one is your solvent. Spelling is wrongly written here. So one is your organic solvent phase and another is your aqueous solution phase. Okay, so you have to dissolve surfactant and cholesterol inside the organic phase. Okay, and if your drug is aqueous soluble, then dissolve the drug in the aqueous solution. Then देखो यहाँ पे क्या होता है, ऑर्गेनिक जो सॉल्वेंट है ना वो होता है इथर, डाईइथाइल ईथर इज बीइंग यूज्ड इन दिस मेथड एज एन ऑर्गेनिक solvent. So that's why it is known as ether injection method. Okay, so ether should be used here in case of organic as a organic solvent. Okay, and you have to pour drop by drop the ether solution, I mean the organic solvent, in the aqueous solution, and you have to go for, after that you have to go for rotary evaporation. रोटरी वैक्यूम इवापोरेटर में आपको ये जो कॉनिकल फ्लास्क है इसको अटैच करना होगा, और जो एक्सेस जो ऑर्गेनिक सॉल्वेंट है वो इवापोरेट हो जाएगा। उसके बाद आपको सोनिकेट करना होगा एंड आपका जो नियोसोम होगा वो प्रिपेयर हो जाएगा। ठीक है, देन कमिंग टू द रिवर्स फेज इवापोरेशन मेथड, दैट इज ऑल्सो इंपॉर्टेंट। इन केस ऑफ रिवर्स फेज इवापोरेशन मेथड व्हाट एक्चुअली हैपेंस, देखो होता क्या है, यहाँ पे दो सॉल्यूशन आपको प्रिपेयर करना है, वन इज योर ऑर्गेनिक सॉल्वेंट एंड अनदर इज योर एक्वस सॉल्वेंट। बट होता क्या है, यहाँ पे आपको एक्वस सॉल्यूशन डालना होगा ऑर्गेनिक सॉल्वेंट के अंदर, ठीक है। उसके बाद उनको सोनिकेट करना होगा, उसके बाद क्या करना होगा, आपको रोटरी वैक्यूम इवापोरेटर में उसको लगाना होगा कॉनिकल फ्लास्क को, एंड द एक्सेस जो ऑर्गेनिक सॉल्वेंट है वो इवापोरेट हो जाएगा एंड आपका फाइनल सस्पेंशन कॉन्टेनिंग नियोसोम विल बी प्रिपेयर्ड। ओके, then coming to the important topic, important method of preparation that is widely used nowadays, okay, that is probe sonication technique। देखो होता क्या है, आपको मिक्स तो करना ही है, ठीक है, ये आपका ऑयल फेज है, ये आपका एक्वस फेज है, आपको तो मिक्स करना ही है। मिक्स करने के बाद जो सोनिकेशन होता है ना, उसको हम प्रोब सोनिकेटर यूज करते हैं यहाँ पे, ठीक है, प्रोब सोनिकेटर यूज करते हैं, और ये आपका होता है प्रोब सोनिकेटर। ओके, ये होता है प्रोब सोनिकेटर। यहाँ पे आपका जो सैंपल है दैट इज प्लेस्ड हियर एंड द मशीन इज रोटेटेड एट वेरी हाई स्पीड। ओके, एंड यहाँ पे होता क्या है, देखो वाटर बाथ है, वाटर बाथ है मतलब ये जो मशीन है ना बहुत हाई स्पीड मशीन है, दैट्स व्हाई हीट इज जनरेटेड। सो टू कूल द सिस्टम, टू कूल आवर फॉर्मुलेशन, सो आपको वाटर बाथ और आइस पैक वो जो होता है वो रखना होता है, ठीक है। सो देन कमिंग टू द नेक्स्ट एंड द लास्ट पॉइंट, इवेल्यूशन ऑफ नियोसोम्स। ओके, सो इवेल्यूशन कैसे करेंगे आप, देखो जो वेसिकल शेप है ना, जो नियोसोम का जो वेसिकल है ना, उनका जो शेप है दैट इज बीइंग एक्चुअली एनालाइज्ड बाय 10 ट्रांसमिशन इलेक्ट्रॉन माइक्रोस्कोपी एंड सेम स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोपी। ओके, एंड पार्टिकल साइज, जीटा पोटेंशियल एंड पॉलीडिस्पर्सिटी इंडेक्स ऑल आर कैरेक्टराइज्ड बाय योर माल्वर्न जीटा साइजर। ओके, जीटा साइजर जो होता है जीटा पोटेंशियल मेजर करता है वो, that is being used in case of your particle size and zeta potential analysis। then coming to lamellarity, lamellarity means कितना आपका lamella है, मतलब bilayer है कि triple layer है कि multi lamellar है, that is being used by, that is being analyzed by your P31 NMR। phase behavior is described, is analyzed by your DSC differential scanning calorimetry। okay, drug release from the niyosomes are studied by your diffusion cell analysis। okay, so these are my references, I hope all of you understood the topic easily। okay, so this is the end of our video, please like, share and subscribe our channel, thank you।